Welcome to myprojectbazaar.com. Here we discuss about performance analysis of ray tracing assisted beamforming techniques for future mmWave wireless systems. Antennas, which are used to increase the capacity of the system and linking capabilities of future mmWave mobile network. Our future mmWave mobile network, that means millimeter mobile wave network, which is operated on high frequency such as 60 GHz basis. Various beamforming techniques are used to describe the mmWave techniques in future mmWave systems. The performance analysis of various beamforming techniques have been carried out using this adaptive beamforming algorithm. They are all least mean square, recursive least square, constant modulus algorithm are available for the estimation of noise estimation. The noise performance and error mean square performance are calculated using this algorithm. Multi-beamform technique, single beamform technique, they are all available to calculate the radiation patterns during the signal transmission in the antennas. And also the future mmWave creation can be extended to home network appliances today. So the radiation pattern and learning curve that describes mean square error deviation of the network and carrier to interference noise ratio are estimated is the main problem. So in this paper the problem of consideration are discussed here. Next, this is the system architecture of our proposed system. Our system architecture consists of 5 modules: 60 GHz network initialization, beamforming, LMS algorithm, recursive least square algorithm, and the comparative analysis of both these algorithms. First module, 60 GHz network creation. It is the base of future mmWave wireless networks. The high-speed data transfer requires a large amount of bandwidth. So, 60 GHz network initialization is mostly suitable for high-speed data transfer application. The quality and robustness of the system are improved by using relay nodes with directional antennas. The use of directional antennas increases the transmission power, efficiency, and the signal-to-noise ratio estimation. Second module, beamforming technique. The creation of radiation pattern of antenna array by adding phase signals in the desired direction and by nulling in unwanted direction is called beamforming. There are two types in beamforming: fixed beamforming, adaptive beamforming. In fixed beamforming, the adjust of weight factors to get optimized pattern of radiation, and adaptive beamforming, the input of multiple antenna to form very narrow beams towards individual users. Second, that is the next module is least mean square algorithm. It is gradient based algorithm which uses the estimate of gradient vectors from the available data of radiational patterns. Fourth module is the recursive least square algorithm. The convergence speed is improved by recursive least square algorithm. To increase the convergence speed, eigenvalue distribution of correlation matrix to be estimated. Finally, comparative analysis. The comparative analysis of carrier to interference noise ratio providing LMS and RLMS are discussed here. Next, we are going to discuss about the running procedure of our proposed system. Our proposed system consists of 3 steps: creation of 60 GHz network initialization with the probability estimation, and LMS application, that is least mean square application, and recursive least square application. Finally, the comparative analysis of these 2 algorithms. Our main function consists of, initially, the first step in our proposed system is creation of 60 GHz network. This network creation involves several number of parameter initialization, that is radiance of relay nodes. This relay node is used to high speed data transfer application, and number of nodes used in the estimation, and number of sectors, the time values, angle of arrival of the beam, then length of the signals, and standard deviation of noise vectors. These are all parameters which is to be initialized before going to do probability isolation. Next, the probability of frequency distribution over the entire process has to be estimated. The frequency distribution of wave creation is the probabilities approach, because the signal and beamforming approaches are adaptive nature. So to describe the adaptive nature, we are going to estimate the probability isolation of within the number of users. Here the number of users taken as 500 number of users. Various number of users are analyzed with each segments. And second one is least mean square application. In this, the signals are calculated from the 60 GHz network, and the power of total power and interference power are estimated for each signal. The difference between the total power and interference power is represented as signal power. Then the signal power and the ratio of signal power to noise power is called carrier to interference noise power. So this CANR estimated in decibel value using LMS algorithm, and the convergence speed of least mean square algorithm is minimum. So to increase the convergence speed, we propose another algorithm called recursive least square algorithm. Using this algorithm, the convergence speed is improved. For that purpose, eigenvalue distribution of each correlation matrix are estimated. Finally, the comparative analysis of or the estimation of CANR using these two algorithms are proposed. Now I run the main file. These are all the output showed using M file. The readings of mean and variance for least mean square algorithm displayed here, and mean variance of recursive least square algorithm are displayed here. Here we are estimating the angle of arrival of beam also. So undesired angle of arrays are displayed in this command window. Now I explain the each number of figures. Figure 1. This shows the histogram together with the probability distribution for number of correlation values. And in the second plots, which shows the probability of isolation for various number of users described. And the figure 3 shows the antenna pattern for least mean square algorithm. And the figure 5 shows it antenna pattern for recursive least square algorithm. And this shows the carrier to interference noise ratio comparison for least mean square algorithm and RLS algorithm for various number of iterations. Here for the comparison, this indicates the CANR value should be minimized below 12.6349 dB. And finally, the learning curve for each estimation has to be displayed. That learning curve, this is the average learning curve for both LMS RLS algorithm. This learning curve provides the standard deviation, square of standard deviation with various number of iterations. Thank you.